Hello my dear students, I hope all of you are doing well. So today we are going to be starting off with a new chapter, that is applications of trigonometry. So I believe that you're already done with the trigonometry chapter. So from the chapter of trigonometry, some of the basic things that if you remember from a right angled triangle, we will be requiring, especially this the concept of the ratios, these trigonometric ratios that we have here. So if you have a right angled triangle where AB is the perpendicular height, AC is the hypotenuse, BC is supposed to be the base, where we have angle C as theta, which is also sometimes called as reference angle. So now if C is theta, then with respect to theta, what happens is, we all know that sine of theta, sine of the angle theta will be equal to what? Perpendicular height, isn't it? The altitude or the opposite side upon hypotenuse, that is AB by AC. Cosine of angle theta would be equal to the adjacent side, or we call it base, adjacent side upon hypotenuse, and tangent of theta is given as opposite side upon adjacent side, or perpendicular height by base. So this few basic knowledge we will be requiring here, and also the knowledge on the 5 specific angles, especially with the 3 specific angles, that is 30 degree, 45 degree and 60 degree, mostly with in class 10 up to class 10 standard, mostly with sine, cosine and tan, or we call it tangent. Okay, so I hope that all of those values are familiar with you. If not, you can always take out the table, keep it in front of you, because see, most of the students, what they generally try to do is like they try to buy hard all those entire table and all. See, who is going to memorize all those stuffs and all. Maths is always learned with practice, not with memorization. Okay, so always feel free to keep the formulas in front of your table when you practice, and then just see to it that it's open in front of you, and then you practice. So maybe in a month, in a week, in a 2, you will find that these values will automatically get into your brain, and then you will start remembering them without actually trying or wasting time to memorize them. So most of the students, what they do is like they hide the formula, isn't it? They hide the formula and then they try to trick themselves by just looking into the formula when they don't know. So don't do that, just keep it in front of your table. Feel free to just go through it whenever you need it, so with that, of course, you will really definitely in some due course of time, you will just know the values. Now some of the applications. So this chapter is about applications of trigonometry. So in this chapter, basically here we are going to be learning about just one topic, that is heights and distances. Heights and distances, that is like how to find out the heights of any figure, any building or tower, or to find out the distance between 2 points using trigonometry. So most of the questions that we have in this chapter, in this exercise, are based on real life situations. Like you have a tall building, so without actually measuring it, if we just have the angle of elevation, angle of depression, or the distance, and how do we really find out the height of that building, or like how do we really find out the width of a river without actually measuring it? It's not possible to practically measure the width of a river, isn't it? So some of the basic applications of trigonometry which we can use in our daily life. So we will see through some questions here, how it is really done, and when time comes, definitely one day when you all become engineers and all, definitely you will see that you start using this trigonometric applications. Now before that, some of the basic things before we really jump into heights and distances is that the ground, some of the ideal situations, some of the things which we will assume now, that is the ground will be generally assumed as a very level ground, okay, a straight line. Alright, that's the first thing. Second rule is like when we talk of a tower, a building, a tree, we will always, until unless it's mentioned in the question with a special condition, we will always assume that it's always standing straight, perpendicular to the ground, this is called the horizontal line. So it is always assumed to be standing straight. Alright, and height, we all know that is the shortest distance, or which is also the perpendicular distance, is the actual height of an object from a level ground. Then of course we have another term which is called elevation. Angle of elevation. So angle of elevation is basically like when you're looking at something that is above you. So maybe like when you're looking at, suppose if this is your head, so when you're looking at maybe the top of a tower, then what happens? We look up, isn't it? So that's like angle of elevation. So from this point, if you're watching the top of the tower, so this is the line of sight, this is the horizontal ground. So the angle formed with your line of sight, that is with your eye to the top of the tower, and the horizontal, this angle is called angle of elevation. Alright, similarly, if you are standing on the, then next we have angle of depression. Angle of depression is generally formed when you're looking at an object which is below you. That is like you're standing at the top of the tower, and then you're looking, maybe you're at the balcony, and then from the balcony you're observing a vehicle or one of your friend who is on the street there. So what do we do is like we look down, isn't it? So that's when the angle of depression is formed. So for that, like this is the line of sight, isn't it? Because we're looking down, and this will be considered to be the horizontal, that is going to be a parallel line onto the level of the ground, and this is the angle that is formed, that is angle of depression. But since this line is parallel to the horizontal, what happens is this angle will be also equal to this angle for our solution, because they will be called what? Parallel lines. So these angles will be alternate interior angles, which we have already studied in class 9. Okay, so these are some of the basic things which we will be requiring in this particular chapter. The rest is simply understanding the question, getting the figure is very important. The rest is very simple. Now let's go to exercise 9.1. I'll not write down the question. I believe all of you have your textbooks with you. Like question number 1. What is the question? It is a circus. The figure is also given in the textbook actually. A circus artist. Oh, I'm using the NCERT textbook, which is also the NBSc textbook. Okay, slightly modified for NBSc, of course. We have these multiple choice questions and all. A circus artist, first question B1, is climbing a 20-meter long rope. So figure for you for this question, luckily it's already given to us. So a circus artist is climbing a 20-meter long rope, so he is climbing on this rope. Tightly stretched and tied from the top of a vertical pole to the ground. Okay. Find the height of the pole. So this is the height of the pole. This is going to be our pole. So find the height of the pole if the angle made by the rope to the level ground is 30 degrees. So we are supposed to find out height of the pole. Alright. So let us just assume, let AB be the height of the pole. Alright, you can take out a pen and paper and then start noting down, because we're going to be doing the solution together. Climbing a 20-meter long rope. So length of rope, that is AC, will be 20 meter. Now the question is, okay, if you want you can write that is angle ACB. ACB is how much? 30 degrees. Now find out the height. Now which ratio gives us a relation between the perpendicular height and the hypotenuse? If C is the angle, then in other words opposite side and hypotenuse. Which angle? Which ratio? Sine, isn't it? Sine of, so in our right triangle ABC, what happens? Sine of angle ACB, sine of angle ACB is going to be equal to AB upon AC. So what is angle ACB? That is sine of 30 degree is AB. AB we do not know, which we are supposed to find out, and AC we know, that is 20 meter. Okay, that's 20 meters. So let's try to find out. Are you done? I'm rubbing it off. So sine 30 we know it is 1 by 2, isn't it? Sine 30 ratio is 1 by 2. AB by 20 meters. So twice of AB, if we just cross multiply, equal to 20 meters. So that's AB is going to be equal to what? 20 meter by 2. That is how much? 10 meter. And that is what our question was. Find out the height of the pole AB. So the height of the pole AB is how much? 10 meters. So if you have time, in conclusion, of course, you can also write that is the height of the pole AB is 10 meter. Alright, let's move to the next question. Question number 2. What is the question there? You can please read the question carefully, read it, because it's very important to understand the question. In the meantime, I'll just have a sip of water, which is very, very important. Question number 2. There is a tree which breaks, not uprooted, breaks, which breaks due to storm. And the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. So if you can just imagine, there is a tree, one part of the tree breaks and then it falls on the ground. So if this is the full length of the tree, then this part breaks because of the storm. So and then this part breaks and then falls on the ground, making an angle. So let's assume maybe this is a level ground. Let's say this was the original height of the tree. Let's say A, B. Alright. Let's say that because of the storm, the tree breaks at this portion, AC. So this broken part, what happens is, okay, it falls down on the ground and hits the ground. So now this broken part is here now, isn't it? Let that point be D. So now we should note that this AC is that same part CD. It's just a broken part only. Alright? And it touches the ground, which makes an angle of 30 degrees. Fine. The distance between the foot of the tree, this is the foot of the tree, this is the foot of the tree, to the point where the top touches the ground after breaking. This distance is 8 meters. Now the question is, find the height of the tree, original height of the tree. So this is the broken part of the tree, one part. So we have to find out this part and we have to find out this part. Now since we don't have a triangle that reaches up to here, no worries, because this part is actually CD, same part. That means if we can just find out CD, which will be same as AC. So now to find out the total height of the tree, it is simply going to be what? BC plus AC. That's going to give me my total height of the tree, that is AB. So let's do a little bit of explanation, exactly how our diagram is, and then we can continue. That is, let AB be the height. You can write down along with me, height of tree. And let's say C be the point where it breaks. So what happens is AC is going to be equal to CD. So AC broken part is also going to be same as the CD only. In bracket, if you wish, you can write down like the broken part of the tree. Alright, so let's just leave it there. If you draw the figure correctly, then it's not very much necessary to explain everything here, because the figure explains everything. So if you have drawn the figure clearly and properly, it will do one job of one part of the explanation part. Okay, so no need to write again, everything is explained there. You should just see to it that your solution also matches with the figure, so that's going to be fine. So now let's find out one by one, because we have only one triangle. So let's first find out this part. Now I have 8 meters. I need to find out this. So what we can do is use which ratio? Tan ratio, isn't it, for angle D. So in triangle BCD, I'll just use directly tan of 30 degree will be equal to what? BC by BD. Now tan 30 is root over of 3, not root over of 3, 1 by root over of 3. BC we do not know, we are supposed to find out. BD is 8 meter. So I'll just continue here. So root 3 by cross multiplying is equal to 8. So BC is 8 upon root of 3 meter. Let us leave it as it is. Let's not do the calculation as of now. Let it be there. Fine. Alright, so this is already calculated. Now let's try to find out the other part of the tree. Also, let's say now you can use this ratio also, or you can use this. Okay, let's just use cost ratio. Also, cos of 30 degree will be equal to what? BD by CD. Now we are trying to find out CD. Cos of 30 is how much? Root of 3 by 2. BD is 8 meters. CD we are trying to find out. That's the broken part. The remaining broken part. Now let's find out. CD into root 3 will be 8 to the 16 meter by cross multiplying, right? So CD is going to be 16 upon root 3 meter. So now you see we have BC and then we have CD. CD is same as AC. But CD is also equal to AC. We already mentioned before. So now we can find out height of the tree. So height of tree. What was it? AB is actually what? AC plus BC. But AC is same as CD plus BC. No problem there. So what is the value of CD? CD was 16 upon root 3 plus what was the value of BC? BC was 8 upon root of 3 meters each. Okay, so all these are now not needed. This can also go now. So common LCM, I'll just simplify this. Root 3, 16 plus 8. So 24 root over of 3 meters. So let's just rationalize this a little bit more. 24 upon root 3 by rationalizing the denominator, root 3 meter. So 24 root 3 by root 3 into root 3 will be how much? 3 meter, isn't it? So 3 ones are 3, 3 eights are 24. So that is 8 root of 3 meters. So this was the original height of the tree. That is 8 root of 3 meters. Okay. Let's do one more question. Just one more question. Alright, fine then. We will leave that question. Shall we do it? Or alright, chalo, let's just do this question. That is question number 3. A contractor plans to install let's do it quickly. A contractor plans to install 2 slides for the children to play in a park. So we have the level ground. So he plans to construct 2 slides for the children to play in the park. For children below the age of 5 years. Below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter. And inclined at an angle of 30 degree. So this is for, let's say, children below 5 years. So let's name it PQR. Done. Whereas for the elder children, she wants to have a steep slide of height 3 meters. So for elder children, she increases the height to 3 meters. She increases the height to 3 meters. and inclined at an angle of 60 degrees. So she wants to make it very much more interesting for the elder children. So let this be A, B, C. This is for elder children. What should be the length of each slide in each case? What should be the length of the slide in each case? So we are supposed to find out the length of this slide. We are also supposed to find out the length of this slide. Alright, so let's continue. Since figure is already mentioned, let's write down PQ be the length of slide for children below 5 years. As I just told you in the previous question, once your diagram figure is properly maintained and then it's properly drawn like this, you don't really have to explain the whole figure again. Very well understood. Everybody can understand from the figure, so it's more than enough. So I'll just go for first part. So in triangle PQR, so I have the height, I have to find out the slide. So height, hypotenuse, that is sine. Sine of 30 degree will be equal to what? PQ by PR. Sine 30 is 1 by 2. What is PQ? PQ 1.5 meter, and PR we have to find out. So cross multiplying, the PR will be 1.5 meter into 2. So 1.5 meter into 2 is like 3.0 meter. So that's equal to how much? 3 meters. So this will be the length of the slide for children below 5 years. Are you done? Shall I rub it off? Okay. Then let's go forward to find out. So this one is done. Let's just rub it off, just to avoid any distraction. So now let's go for the slide of AC. So I'll just write here, and let AC be the length of the GTH of the slide for elder children. So in triangle ABC, again same ratio, sine of 60 degree will be equal to AB by AC. Sine 60 is root of 3 by 2. AB 3. AC we have to find out. Now cross multiplying, root of 3 into AC equal to 3 to just 6. So AC will be equal to 6 upon root 3. So we will just rationalize this. That is again root 3 upon root 3. So that's going to be 6 root 3 by root 3 to root 3. We have already done just before 3. So 3 ones are 3, 3 twos are 6. So that's 2 root of 3 meter. So basically, if you get time, in the last step, you can always write down that is like length of the slide for elder children is 2 root of 3 meter. In the same way, you can also write length of the slide for the children below 5 years is what? How much was it? 3 meters. Right, 3 meters. So that is what basically this height and distance problems are all about. So as you see that it's not difficult at all. Actually, no, absolutely not. It's not difficult at all. I know you can do it, but the only concern would be, understanding the question, drawing the figure, getting the figure done. That's going to be your most important part. All right, understanding the figure and then drawing the figure. Because once you draw the figure, then it's all about using the trigonometric ratios. All right. So fine then. So lots of learning to be done in this chapter. In the next video, we will try to solve some more questions on height and distances. So I hope I could be of some help. I hope that you've liked the video. If you've liked the video, please do let me know. Please subscribe as well as share with maximum of your friends also. So till then, see you in the next video. Till then, take care, stay safe. Bye-bye.